Hello everyone, this is Calculus 3 Final Exam Review. We'll be doing 28 questions. And of course, these 28 questions cannot cover everything, every type of Calculus 3 questions. To do that, we will need like 280 questions to do it. But I tried to make questions that cover most of the material that is in Calculus 3. So if there is any part in this solution and the question that you haven't fully understood, then you should try to mark that down and look at the textbook for more questions and look at the notes and more examples and other videos. Don't try to just memorize the steps because that's not going to really work for the final exam. Let's begin. Okay, so we have these two vectors, actually three vectors, and you're asked to compute these various operations, dot products, cross products, and components and projections. So let's see. First, u dot v. There are actually two types of formulas for u dot v, right? So dot product is given as u dot v equal to the norm of the first thing times norm of the second thing times cosine of the angle between. These are vectors. And that's the case when you don't have the coordinates of each vector, but you have the angles between. If you have coordinates of u and v, then you would do a, b, c dotted d, e, f as a times d plus b times e plus c times f. Okay. So let's see, u dot w. What do we have? We have u listed as magnitude and an angle, but then there is another vector w of magnitude 5, which is 60 degrees apart from vector u. So w does not have any coordinates to use the second formula. Therefore, we have to resort to the first formula and then do the following. If I need u dot w, I would need to do norm of the u times norm of the w. I'm putting these arrows in because these are vectors here. It's using boldface font to show that it's a vector, but I can't. So I'll just put arrows on the top. But it's the same thing. Okay. And then we have cosine of the angle 60 degrees. Let's see, what is the norm of u? Norm of a vector is computed by taking the square root and adding the squares of each components. 1 squared, see, then times w's magnitude is 5, and then cosine 60 is 1/2. That's square root of 16 plus 1 plus 1 times 5 over 2, which is square root of 18 times 5 over 2. Square root of 18 becomes 3 radical 2 because 18 is 9 times 2, as 9 is a perfect square, so you can rewrite it as 3 radical 2 over 2 times 5, whose answer is 15 radical 2 over 2. Okay, so that's the answer to A. Okay. Now let's try B. U cross V. Let's see. In this case, well, U cross V cross products are computed by the following formula. I, J, K. You have the standard unit vectors, and if you have two vectors A, B, C, and D, E, and F, you compute this determinant. That's how you calculate the cross product. Now, if you don't have the coordinates of a cross product, then the way to get the cross product just from the description by angles and stuff, you can use the following formula. For the magnitude of U cross V is norm of U, norm of V times sine of theta, whereas the direction, U cross V, has the direction, this is perpendicular to both U and V, and this is given by right-hand rule. Okay, so it's actually very complicated to compute the cross product of a vector when it's not given as coordinates. Okay, so let's compute. So you have ijk, and the vector u is 4, negative 1, 1. V is negative 2, 0, 2. Okay, so u and v are given as coordinates, so it makes sense to use this formula. Now let me talk about this v here. V is given as negative 2 plus 2k. So this is really what? Negative 2I plus 0j plus 2k. And therefore it should be thought as negative 2 comma 0 comma 2. That's how you should think of it, okay? And it's good to change, whenever you're in ijk notation, it's good to change to coordinates before you use any formula, because if you put this into the formula, often the common mistake is to put ijk inside this matrix, and you end up with a completely wrong answer. Alright, so let's continue. So there are many ways to compute this determinant. So you may do this differently, but the way I do it is I do this row expansion. So I choose I, and there's this checkerboard of signs. It's plus, minus, plus. And then choose I, and then delete the column and the row containing I. So you end up with this here. So that's the matrix I'm going to write. So it's negative 1, 1, 0, 2. The submatrix here, and then I put I. And then I go to J. The checkerboard of signs says it's minus J. Let's put J with the minus. And I put the row and the column deleted, gives you 4, 1, negative 2, 2. So it's 4, 1, negative 2, and 2. And then if I choose K, that's plus. There's 4, negative 1, negative 2, and 0. Alright. And then these are computed as AD minus BC, so you do this, right? The first one, if I do AD, negative 1 times 2 is negative 2. Minus BC, 1 times 0, that's 0. So if I do negative 2 minus 0, you get negative 2. 4 times 2 is 8. 1 times negative 2 is negative 2. 8 minus negative 2 is positive 10. And you put a minus in front. It's negative 10j. This is 0. This is 2. 0 minus 2 is negative 2. And that's it. That's the cross products of the two. Okay. Now let me go to the next question. C, angle between u and v. Well, for this, the formula is that cosine of the angle between is u dot v divided by the norm of u of v. You may notice that this is really the previous, this formula right here. This one right here. And if you take this formula and divide it by if you take this formula and solve for cosine theta, then this goes to the other side, and you get exactly this formula here. Okay. All right. So let's compute. We actually have. We actually need to calculate the u dot v, and u and v are given as coordinates. Remember, this should be thought as -2, 0, and 2. So 4 times -2 is -8. -1 times 0 is 0. 1 times 2 is 2. And you take the square root of, well, we did this before in the previous slide. It's square root of 18. Now for v, I need to do square of -2 squared plus 0 squared plus 2 squared. And then that's 6 over square root of 18. And then there's 4 plus 4, that's square root of 8. Okay, and then let's see, this is 9 times 2, so 3 comes out from the first one. This is 4 times 2, so 4 comes out. No, not 4. 2 comes out. So 2 comes out. Square root of 2. And then you see that square root of 2 times square root of 2 is 2, right? So you have 3 times 2 times 2, because square root of times square root of 2 is 2. And then 6, and you see that this is 6, that's 6, so they can cancel out, leaving you with 1/2. All right, now the question is, for what angle of theta is this cosine of theta equal to 1/2? And the answer is theta is 60 degrees. Or in radians, it's pi over 3. Okay, so you should remember the values of the cosines and sines for special angles. And also, special angles like 30, 45, 60, 90, and then 120, 135. All these angles, you have to know them in order to solve these kind of problems. Let's see. C. Okay, then let's go to D. Okay, you have V dotted with U cross V. Okay, so what do we know about the cross product? Cross product, we know that it's a vector that's perpendicular to both u and v given by the right-hand rule, and the magnitude of this vector is the area of the parallelogram given by u and v. So if this is u and that's v, and then you think about this parallelogram, the parallelogram area is going to be the magnitude of this, which is norm of u times norm of v times the sine of the angle between. And this u cross v is perpendicular to both u and v. So whatever this is, it's going to be perpendicular to v. Now the question is, what is the dot product between two perpendicular vectors? Because of the formula that we had previously, which is, the formula previously was that it's u dot v is u times v times cosine of the angle between. What happens if the angle is 90 degrees? Cosine of 90 degrees is 0, therefore whenever you do a dot product of two vectors that are 90 degrees apart, you're going to get 0. So 0 is the answer to D. Alternatively, you can also use the following formula. The triple scalar product is given as the following. If you have A, B, C as U, V as D, E, F, and W as G, H, I, the triple scalar product is equal to this this matrix, okay, and this matrix determinant. And therefore, since it's VUV, you could have computed -2, 0, 2 for V, 4, -1, 1 for U, and then -2, 0, 2 for V again, and you can do this long determinant calculation only to get 0 at the end. But this takes too long. I mean, just knowing that the dot product of two vectors which are perpendicular gives you 0 is not only useful for this question, it's also used in several other contexts. So it's a very important thing to know. Okay. E, component and projection. Okay, so what's a component? These are just formulas, but I guess understanding the formula helps you in memorizing them. So it's like this. If I want V's component in the U's direction, that's what this means. It's the following vector. I take a projection of V onto U, and this length right here, this length here is what we call component of V in the direction of U. Okay. Clearly what this is showing is that it's really what we want is the length of V times the cosine of the angle between the two vectors, right? That's how you compute the projection. And this is same as multiplying by U and dividing by U. And the top one is really U dot V, and then you're dividing by U. Okay, so you can think of this as the formula for the component. Alright, we already computed U dot V somewhere. It's here, right? 6. And then this is a norm of U, which is square root of 18. So in our case, the answer would be 6 over square root of 18, which is 6 over 3 radical 2. 3 and 6 cancels, and you get 2 over radical 2. If you rationalize the denominator by multiplying by square root of 2 top and bottom, you end up with 2 radical 2 over 2, which is radical 2. So this length here is radical 2. That's what we found. Now, projection of V, U of V, is this projection is just this one, but now turned into a vector. Okay? So the difference between the component and the projection is you turn this into a vector. The way you turn a magnitude into a vector is you just multiply by the unit vector in that direction, right? So in order to do F, we had the component equals to radical 2, and the picture was this V, U, things like this. We want this part. I want this to be the vector. The length of this is radical 2, that we know. What's the unit vector in this direction? To get the unit vector in any direction, you take the vector and divide its divided by its norm, then you get the unit vector in that direction. This het means it's a unit vector. And in our case, it's 4, -1, 1 over, the norm is 3 radical 2. We computed it. So that's our u. Now what we have to do is we multiply this radical 2 to this to get the projection. Therefore, the projection of vector v over onto the vector u is radical 2 times 4, -1, 1 over 3 radical 2. Radical 2, radical 2 cancels, and you get 4 over 3, -1 over 3, 1 over 3. Because if you divide by a number, it divides to each element. So that's the projection. Now, alternatively, you can use the formula, which is, the formula for projection is u dot v over u norm squared times the vector u. Okay. You could use this, but warning is that this is a very confusing formula to memorize, because sometimes the question asks projection of u over v. In that case, u and v has to be switched, and because this is not so symmetric, it's hard to get it right. So often, knowing the geometrical definition and trying to work it out in this way might be easier. Okay. Now, area of the triangle formed by u and v. So if you have the area of a triangle formed by u and v, so let's say this is u and that's v, we're looking for the area of this triangle. Now we learned that the norm of the cross product gives you the area of parallelogram. Okay, and that parallelogram is really this parallelogram. Okay. And if you look at this, the area of the parallelogram is just twice the triangle. Or in other words, if I want this area of the triangle area would be half of u cross v. Okay. And we computed u cross v before. What was it? This was -2, 10, -10, -2. So what we need to do is to take the norm of -2, -10, -2, and calculate -2 square root of -2 squared is 4, 10 squared is 100, -2 squared is 4 again, so it's 1/2 of square root of 108. I think this is divisible by 4. It's 4 times 20, let's see, 27, 4 times 27, okay. So it's 1/2 times 2 radical 27. And 1/2 and 2 cancels to give you radical 27. And then 27 also has a complete square, right? And it's 9 times 3, and 9 comes out as 3, so it's 3 radical 3. Okay, let's go to the second one. Find the equation of the line passing 2 points, 1, -2, 1, 3, 1, 0. So, to get the line equation, you need to remember the formula for the line equation. There are two things: the parametric form and the other one is the symmetric form, which is x minus x0 over a, y minus y0 over b equals c minus c0 over c. So there are two types of line equations. Since it says in both parametric form and symmetric form, you have to find these all together. But in both cases, you need the direction vector, the a, b, c, is a direction vector. That's the direction of the line. It's different from the slope, because slope is like the ratio of things, and if you have three numbers, you don't know what to do with the ratio, right? But it has the same function as the slope because it gives you the direction, and slope also tells you the direction. Okay. And then x0, y0, z0 is a point on the line, and in our case we can pick either of the two. Let's pick 1, -2, 1 as the first one. Okay. Now direction vector. Direction vector. How do you get the vector? Vector is always terminal minus initial. So you do terminal minus initial to get the vector involved here. And 3 minus 1 is 2. 1 minus -2 is 3. 0 minus 1 is -1. Okay. So that's the direction vector. This is the point, and we finally write it as, in parametric form, 2t, 3t, -1t from the direction vector. Now we have to put 1, -2, 1 from the point. That's the one in parametric form. In symmetric form, it's x minus 1, x minus x0, so x minus 1 over the first number, which is 2, equals to y minus -2. Y minus -2 is y plus 2, divided by 3, and z minus 1 over -1. So you have to write like this. You can also simplify this as like 1 minus z, right? This is same. This one is same as 1 minus z. So you can use that. Okay. Find the equation of the line perpendicular to the plane passing to 1, -1. In this case, it said find the equation of the line, but it didn't say parametric or symmetric, so you can just put one of the either. Here, you have to know that the generic line equation looks like ax plus by plus cz equal to 7, equals to some number d, and this a comma b comma c is a normal vector to the plane. And then d, it plays no role in the vector. It just changes, d changes how far you're going to be off from the origin. So if the plane is right at the origin, d would be 0. If plane is far from the origin, d would be a big number. Okay. All right, so a, b, c, that's the normal vector. Normal means perpendicular. So if you have a plane, the normal vector is this vector which is perpendicular to any vector on this plane. Okay. All right. Now what are we looking for? We're looking for a line perpendicular to the plane, and because the normal vector is already a vector that's perpendicular to the plane, that means we can use this 3, -4, and 2 as the direction of this line, because a line that's in the direction of the vector is actually going to be perpendicular to our plane. So let's use that. So the vector 3, -4, 2 is our direction vector, and 2, 1, -1 is the point it should pass. So let's write it x, y, z equal. It's 3t, -4t, 2t from the directions, and plus 2, plus 1, minus 1 from the point. Okay, so that's the answer. Okay, that's the answer. All right, next question. find the plane equation passing through 3 points. Right. So as I said, generic line equation form is ax plus by plus cz equal to d. So one thing you can do is you can just plug in these values here. For example, 1, 0, negative 1 means a plus 0 minus c equals to d. So you get an equation between a, b, c, and d, right? So you plug this in, and you get 3 equations. Now, you should be getting 4 equations if you wanted a, b, c, and d, 4 unknowns, right? The reason for having only 3 equations is that because you can take this, and if you want, you can divide everything by a, so that this is 1. So you can basically think of the generic line equation as x plus some b, y, so this is b prime, c prime, y, z equals to d prime, where b prime, c prime, d prime are just new numbers, which are really this. Okay, well, this is kind of hard to do, so let's not do it this way. So let's try another method. So another method is to use the following formula for line equations, generic line equations. Just like we have point slope form in 2-dimensional line equation, the 3-dimensional line equation is something similar, which is ax minus x naught plus b y minus y naught plus c z minus z naught equals to 0. Okay, where x naught, y naught, z naught is the point it passes, and a, b, c is the normal vector. Now, because this is the normal vector, think of it like this. You have 3 points on the plane. So you have a, b, c, 3 points on the plane. Now, to get a normal vector, you can think of the vector connecting the first 2 and this. And if you take the cross product of the 2 vectors, then we know that cross products produce a vector that's perpendicular to the previous 2 vectors, right? And because the entire plane is plane contains these 2 vectors, every vector in this plane should be perpendicular to this vector. So that's how you get the normal vector. So that's one way to do it. Okay. So let's see. This is how you do it. You take these 2 vectors, subtract. So 1, 2, 0. Terminal minus initial gives you 0, 2, 1. So that's one vector. And let's take a vector between these 2. Okay. So you have terminal minus initial. 2 minus 1 is 1. 1 minus 0 is 1. 4 minus negative 1 is 5. And then you do the cross product. Okay, 0, 2, 1, 1, 1, 5. And that's I times, let's see, 2, 5, 1, 1. And then minus j times, if I take j and delete, I get 0, 1, 1, 5, plus k times 0, 2, 1, 1, then k. And then it's 10 minus 1 is 9i. This is 0 minus 1, but there's a minus, it's plus j. And this is 0 minus 2, so it's negative 2. So that's the vector. Okay. That's your normal vector. You should write this in notations not using ijk. It's 9, 1, negative 2. That's your normal vector. And please, when you have ij and k used to write a vector before you do anything with it, please change it to this regular format. Okay. All right. Now let's apply this formula. This formula is 9 times x minus, well, I have to pick something is x naught, y naught, z naught. So let's say this one, okay? X naught, y naught, z naught is this vector here. So it's x minus 1 plus 1 times y minus 0, and then minus 2 times z minus negative 1 equal to 0. And then finally, if you have 9x minus 9 plus y sorry, something's wrong. Okay. Plus y, and then you have minus 2z, and then let's see, this is plus 1 times negative 2, so it's negative 2 equal to 0. And then I have negative 9 and negative 2, that's negative 11, that can be moved to the other side. So in standard form, it's 9x plus y minus 2z equal to 11. That's your answer. Now let me show you there's another method. It's slightly quicker, but it's just another thing that you have to memorize. So if you can't remember, it's good to do it this way. All right, so another slightly easier method is following. If we have two vectors, my PowerPoint is complaining. Okay, if you have two vectors and you have this blue dot which is on the plane, then think about this third vector and think about these three vectors. They are on a plane, right? And we know something called volume of the parallelopiped. Volume of the parallelopiped is the determinant. The meaning of the determinant is the volume of the parallelopiped, right? So if I have the two vectors, you still have to get these two vectors. If I have the two vectors 0, 2, 1, 1, 1, 5, and let's say x, y, z, is a point on the plane, then the volume of the parallelopiped should be 0 because it's a flat parallelopiped, right? So this has to be 0, and if you compute this determinant, you'll see that it's exactly the same as this one. Okay. Now we want to find the equation of the plane passing through these 2 points and is parallel to the line this. Okay. All right. So we have a point already. So remember, we're trying to find the equation of the plane by using this formula. And therefore, if I have x naught, y naught, z naught, then half the problem is solved. Now all you have to know is ABC. ABC is a normal vector which can be obtained by taking the cross product of two vectors on this plane, and that's 2, 3, 0, 1, 1, negative 2. If you do terminal minus initial, you get 1, 2, 2. So that's one vector on the plane. So we know that 1, 2, 2 is one vector on the plane. And this direction vector, by the way, this is really z minus 0 over negative 1. So the direction vector from here is 2, 5, negative 1. And if you take the cross product of these two, because this is on the plane, and because this line is parallel to the plane, this vector is also so in the plane. So it's like this. if you have this plane and if you have a line which is parallel, the direction vector can be brought over here because vectors can be moved all the place around without changing the direction, right? So if you move it, then it becomes a vector inside the plane. So it's a perfect candidate to use to do the cross product to give you this normal vector. So let's compute ijk. Let me do this a little fast because we've done this several times by now. Multiply -2 minus 10, -12i. Choose j, -1, minus 4, -5, but j has a minus, it's plus 5j. And then k is 5 minus 4 is plus 1k. So that's your normal vector, which is -12 plus 5 plus 1. And then you use 1, 1, -2, so it's x minus 1, y minus 1, z minus -2, which is z plus 2, equal to 0. -12x plus 12 plus 5y minus 5, z plus 2 equal to 0. So you get -12x plus 5y plus z. 7 plus 2, that's 9. So it's -9. So that's your answer.